Okay, on problem 19, we have a boat that's sailing due east. So first of all, we set up some directions. We have north, east, south, and west. So this boat, let's just pretend that it's starting right at the origin of this graph. So here's where the boat's starting. And it says it is sailing due east at 10 miles per hour. So all we know is at some point, the boat is going to be here, and we don't know this distance yet. So here's boat where it is first, and then where it is second. So then we're told that there's a lighthouse, and at one time the lighthouse is south 70 degrees east, and then 15 minutes later it's south 63 degrees east. So I know the lighthouse is east of both of these points, so I'm just going to put it somewhere over here. So this could be our lighthouse. L. So this is our triangle. So if we connect the sides, we have this triangle. And then we can label two of these angles and one of the sides actually with the information we have. So first, this red side, the distance the boat travels. It says the boat is going 10 miles per hour. And these two measurements for the angles to the lighthouse were taken 15 minutes apart. So we can do a conversion of 10 miles in 60 minutes, because it's 10 miles an hour, equal to how many miles in 15 minutes. So you can cross multiply that. And in the end, you would get that x equals 2.5 miles. So that tells us this red side is 2.5. And then we know two angles. So we're told the first measurement, the lighthouse is south 70 degrees east. So that means if I drop a line straight down south right here, it's 70 degrees east. So that is a 70-degree angle, which means the angle inside the triangle is a 20-degree angle, because this is the right angle, so it should form 90. Similar idea, if I drop a straight line down from the second position the boat is at, and it is now south 63 degrees east, so this angle 63, and this is a 90. So overall, that angle for B2 is 90 plus 63, which is going to be 153. And then while we're at it, we can just find angle L. So 180 minus 20 minus 153 would leave us 7 degrees down here. Okay, so that's all the information you need from the problem. Now you can actually solve it. So if I redraw the triangle separately so that we can see everything a little better, we have a triangle that basically looks like this, and this side is 2.5, and this angle is 20, and this angle is 153, and this angle is 7. Okay, so there's two ways to go from here, because what do we actually want to find? We want to find how far the boat is away from this other shore over here. So that this green could be the shoreline, and the lighthouse is right on the edge of the shoreline. So we're looking for these distances straight from the boat to the shoreline. This would be considered D. So we have two options to do this. We can either use law of sines on this triangle to find this side that I'm highlighting in orange, which over here is this side. And then we can form a right triangle that I just made in orange, and we can use sine, cosine, or tangent to find this side D, which is the answer that we want. So that's one option. The other option is I can find this side that I'm highlighting in pink using law of sines again, and that would give us this right triangle, pink. And again, same idea. You can use sine or cosine or tangent depending on what sides and angles we end up having to solve for D and the pink triangle as well. So two options, basically the same thing both ways. I'm going to solve for the orange side. So looking back at the triangle on the left, the orange side is across from the 20. So that's going to be, call it X. It's going to be X over sine 20 equals 2.5 over the sine of 7. And if we solve this by multiplying the sine 20 over to the right side, we would have 2.5 times the sine of 20 and then divided by the sine of 7, which X comes out to 7.016 miles, because that's a side length, so that's still in miles. Okay, so we have found this side is 7.016 miles. So again, I now have this right triangle in orange where I know this side, which is the hypotenuse, and I can use, looks like cosine is what we'll end up using to find D. So if I draw that orange triangle out separate, we have up here a 63-degree angle. So 63, 90 degree, 7.016, and D. This is the side we want. So as you can see, we will use cosine because we have adjacent and hypotenuse for this angle. So that means the cosine of 63 should be equal to the adjacent D over the hypotenuse, 7.016. We would solve by multiplying the 7.016 over to the other side. So if I do that times the cosine of 63, I end up with 3.19 miles, which is the answer to the question because we want to know how far away from the shoreline is the boat.